So today we got a medium problem again. First time, find the city with smallest number of neighbors at a threshold distance. So you got n cities, number 0 to n minus 1. We got some weighted bidirectional edges and distance threshold. Returns smaller that are reachable through some path at most. So you want to find something like the furthest city. How many cities are there? 100 only. Oh my days. I mean, okay, there is 10,000 edges. So if you just run from each I mean, I guess I should be able to do. Or city 0 is 1 and 2. So okay, so well, my intuition is that I can just run some sort of maximum dp from slash dijkstra from each vertex, and since it's 10,000 squared, so that might run faster. The number of edges can be a lot. But I guess we can just run dijkstra from everywhere, I think. I mean, we can try, I guess. So let's do it. So for each vertex we want to find the number of vertices that are at a distance different from the current starting vertex, at most v, and we want to pick the vertex which has the least of those vertices. So it has at most n minus 1 vertices at the distance, so we can safely assume the answer is n at least. And then for each starting vertex we first have to make the adjacency graph. Edges, this needs to be like, what are the weights? Weights are 10 to 4, and there can be 10,000 of them, so that's 10 to 4, so max distance can be 10 to 8. So we can safely use ints pair int x0 push back x1 x2. Let's put 0 here. Nice. Okay, now okay, well, we need to have some distance array with some values like this, and distance of s is 0, and then have some sort of priority queue which will be set for our purposes, sorted by distances, and then while not pq empty. We want to take out the first element, so let's do vertex is PQ R begin, second PQ erase PQ R begin. That might work, I'm not sure. And then we go through all the so wait, if v doesn't equal, so let's save the answer for current. Int current is this. If distance of v is smaller than or equal to distance threshold and v is not the starting vertex, then current plus plus, and then we go for auto pair in something in the adjacency matrix of v, and then we have u p first and w p second, and we have to compute the new distance. So can this get stuck? I probably need some processed vertices, so but then I would solve longest path if I do this. That's not gonna work, bruh. Maybe I need I think I actually just need Floyd-Warshall, because this is not gonna work. This is not gonna work. I cannot solve longest path like this. That is ridiculous, bro. Ridiculous. Okay, so let's comment this out for now, so that I don't lose the code. And let's do this. Let's make a just distance matrix, which will have these distances. Let's call them -1. On diagonal the distance is 0, and then we want to go through the edges, and then diagonal x0 x1 is x2, and diagonal of x1 x0 is also x2. And then we want to do some Floyd-Warshalling, which we basically try to go through all paths. We try to find maximum distance between ij through vertices up to 0, up to 1, up to blah blah. It's a construction used in proving that that you can generate regular languages using regular expressions, I think. Something like that. So, oh, I'm gonna sneeze. This is gonna be so bad. Okay, is the audio even listening? Probably not. Hello there. There is no audio today. Why is that? Whatever. Who cares? I don't care. I don't have time to edit this shit, so let's go back to this. So I can't erase by backwards iterator. How is that possible? How is this distance 60? How can you get to that vertex in 10? Can you tell me, please? That is ridiculous, nigga. I don't know. I mean, I already did that. Why am I doing these maximum path sheets, bro? Why am I doing this? Why am I doing this? Oh my god, bro. Why am I doing this? I'm so fucking stupid, bro. So stupid. Okay, well, how many times we run it? N times, and number of edges is at most n squared, and dijkstra has a time complexity of number of so that's n squared times log n, so n cubed log n